Hello everyone. Today we are going to understand the isolation levels in database. This is an interesting concept and this will help you in various applications plus the database. So before we get into the various isolation levels, let's understand what is a dirty read, what is a non-repeatable read, what is a phantom read. These are basically called as transaction anomalies, or you could say read phenomenon. If you understand this, then these isolation levels will become easier. So let's understand this. See, there are three types of transaction anomalies. First is dirty read. So when we say dirty read, it means uncommitted data. A data which is actually uncommitted is called as dirty data. And reading that dirty data is called as dirty read. Now let's understand this from an example. Say my transaction T1, so it started here at particular time T2, it updated the balance to 500. Now at time T3, there was another transaction. It tried to read this balance. See, earlier it was 1000, it got updated to 500. Now when T2 is reading it, it reads as 500. And if you look here, after T2, we have not committed it. It is still uncommitted data. This uncommitted data is a dirty data. So this T2 is basically doing a dirty read. So that's what it is doing here. And what happens at T4? The transaction T1 rollbacks. And see, the problem is T2 is using this 500 in the application logic. So this is the problem with dirty read. So we are reading uncommitted data or dirty data. So this is the first transaction anomaly or read phenomenon. Now the second one is non-repeatable read. So what happens basically within the same transaction, say T1, when I'm executing the same query, I'm getting different results. Within the same transaction at different timelines, I'm getting different results for the same query. Just keep this in mind. So when we say non-repeatable, so read basically. So if I'm reading data, it is not getting repeated. So this is non-repeatable within the same transaction. Now let's understand with the example. See, transaction T1, it first reads the balance at time T2 and it got 1000. Now in between, there was another transaction T2 which began the transaction at T3. It updated the balance to 1500 and committed it. So by the time T1 again tried to read the balance, it got 1500. So there was a different results for the same query within the same transaction. So same row, different values. So same row, different values in the same transaction. That is non-repeatable data. So just keep this in mind. And the third one is phantom read. Now what happens in this? This is basically your number of rows or records. Those change actually. It is again for the same query. So it is like non-repeatable, same query, but in non-repeatable, you are dealing with that same record, that same one particular record. But in phantom read, your result sets, your records change. Let's understand from the example. At time T2, transaction T1, it runs this query and it gets two rows, John and Sam. And at time T3 and T4, there was another transaction T2, which actually inserted one more employee, say David, and it committed it. And at time T5, when it again executed the same query, it got three records. So this is phantom read. So your number of rows changes. It could disappear also. We could have a delete. So that is the phantom read. So these are the anomalies. So let's recap it once again. In dirty read, what changes? Data is not committed, and still we read it. So that is dirty read. Non-repeatable read, value of the same row is changing in the same transaction. Phantom read, number of records is changing in the same transaction. Okay. Hopefully you understood these three anomalies. Once you understand this, the isolation levels becomes much easier. Let's move to the isolation levels. Now let's look at the isolation levels with these three read phenomena or transaction anomalies. Read uncommitted. See, with the name itself, we are saying it will read the uncommitted data. So transactions that can read data that has not yet been committed. So obviously, dirty read would be possible, right? Uncommitted data. Dirty read means uncommitted data. So this is allowed. And in case of non-repeatable read, obviously this would be there. If dirty read is there, then obviously non-repeatable read will occur. And same for the phantom read. So in read uncommitted, all these three anomalies are possible. Now in read committed, that is the second isolation level. Before this, read uncommitted, right? So we have lowest isolation and highest concurrency. So when we say lowest isolation means it is like T1, T2, they are all colliding with each other. That is where we see lowest isolation. And the highest concurrency means multiple transactions are executing and it is not blocking or creating locks or something. That is the we would say lowest consistency. Now the second one is read committed. So this is the default in most database. As you can understand, read committed data. So simple, you will not allow dirty read. So it prevents. So till the data is not committed, it won't come in the transaction. So that's dirty read. Dirty read is prevented basically in read committed. Now non-repeatable read, if you remember, same row, different values, but it was committed. Just keep that in mind. So that is why it is possible. So within the same transaction, you would see different results if the value is committed, record is committed, sorry. And similarly for phantom read also. If the record is committed, your insert delete will change the number of records. That's phantom read. Now the third one, repeatable read. Now this is the strongest consistency. Little bit of concurrency. Now when we say repeatable read means it is guaranteed. Obviously the uncommitted data won't be there. And even this case, non-repeatable read won't occur. So here what will happen, T2 cannot update the rows read by T1 until T1 commits. T1 sees the same value. So T2 is blocked. That is repeatable read. Here is the example. This is and repeatable read. It is basically the phantom read. It all depends on the database implementation. It is different for different databases. Mostly it would be prevented. The fourth one is serializable. Now this is highest isolation and lowest concurrency. The transactions would be very slow in the serializable. So everything is prevented here. Everything is prevented here. No dirty reads allowed, no non-repeatable reads allowed, and no phantom reads. So basically, if you look here, right, range of rows. So no news. It is like table level lock. So your whole table is locked. In non-repeatable, so whatever rows that you're reading, right, or you might have applied the lock, so row level locks. So it will prevent all that, and we'll wait for the other transaction to complete. And no dirty reads obviously. This is very rarely used. This might be used for very critical conditions. And just keep this in mind. You can apply isolation levels at transaction level. It is also there by default at the database level, but you can override it for transactions. It depends on case to cases. Most default is read committed. As you can see, PostgreSQL uses read committed. MySQL, it uses repeatable read, and Oracle is read committed. SQL Server is read committed. SQLite is serializable. So higher isolation, like you can see, is highest consistency, and lowest isolation is equals to lowest consistency. So it all depends on the performance and business needs. So these isolation levels are also used in the Spring applications, where we can apply the isolation levels. Thank you so much. This was about the isolation levels in database.